Welcome to setting up a hypothesis test for a mean. In these problems, we're going to do several things. Let's review those things. According to our steps for hypothesis testing, we'll want to find and write the claim using the parameters mean, standard deviation, or percentage. We will need to also think about the detailed scenario and the inequality in words. Next, we'll need to set up the null hypothesis, which contains less than or equal to, greater than or equal to sign, and the alternative hypothesis, which remember contains less than, greater than, or not equal to. The next thing we'll need to do is draw the claim arrow, or indicate where the claim goes. Does it go with the null hypothesis or the alternative hypothesis? Remember, it depends on the equality. Last thing we do in setup is we're going to use the null and the alternative hypothesis in different ways. We're going to use the null hypothesis to have the underlying assumption, or the claimed mean, claimed proportion, or claimed standard deviation. We're also going to use the alternative hypothesis to determine the tail and significance level and find the critical value. We're going to look at to see if it's a left tail, right tail, or two-tailed test. Back to our problem. It says the mean of IQ stat students is at least 110. So the key words in here is we're looking the claim about a mean, and the inequality is at least, and the parameter is going to be 110. Since we're testing the claim about a mean, we're going to use the mu symbol. So we're going to put mu with HO and HA. The inequality symbol is at least. At least is going to be greater than or equal to. Since it's a greater than or equal to sign and it contains equality, that greater than or equal to sign is going to go with our null hypothesis, H sub O. And then we're going to have our parameter, which is 110. So now we will read our H sub O as mu is greater than or equal to 110. Remember, again, this is where our claim is going to be because it contains equality. It's going to go with the H sub 0. Our alternative then is, think about this. If it's not true, if the null hypothesis is not true, if it's not greater than or equal to, it's going to be less than. And we're going to still use the same parameter of 110. Other things that we can notice after we have set this up is the fact that, again, we can use the underlying assumption. We're going to use the null hypothesis to assume the population parameter for our claimed mean. Mu sub 0 equals 110. So we're going to use that in later on in our calculations. We also can look at our alternative hypothesis, and since it's a less than symbol, we know that this is going to be a left tail test. And that's all we're going to do and notice in our setup of our hypothesis test. The next example is very similar. It says the mean IQ of stat students is at most 110. So we're going to say here that the mean is at most 110. We're going to look to find the key words in this. We're testing a claim about a mean again, so we're going to use the population mean symbol mu for both the null and the alternative. And at most. At most symbol is going to be the less than or equal to symbol. And since it is equal to, we're going to have the claim go with our null hypothesis, H sub 0. So that's going to be now less than or equal to, our parameter is going to be 110. So H sub 0 should be mu is less than or equal to 110. H sub A then is if it's not true. If mu is not less than or equal to 110, then it's greater than 110. So our alternative is mu is greater than 110. Again, we're going to assume then our claimed proportion, or our claimed mean, is mu equals 110. Sorry, let me bring it over here so we can get to it. Our mu sub 0 equals 110. Our alternative hypothesis, mu greater than 110, indicates that this is going to be a right-tailed test. So some of these other things are important later on when we talk about performing the entire hypothesis test.